Cool. So Archive Papers LLM. So most of you probably know of AK on Twitter. I constantly see the tweets. I bookmark them. Think I'm gonna actually read them. I don't. One thing we started doing is that we both use Claude. We just download papers, upload it, ask it questions. But we only have like 5 PDFs to upload. So we thought, why not scrape AK's timeline and just fine tune an LLM with it. And so that's exactly what we did. And so Meta just released this OCR model. And so we thought, okay, instead of just converting it to text or using something online, why don't we just use this? Creates a MMD file, and it even creates latex format for it that we can actually fine tune on. And you can talk more about that.
Yeah, it essentially brings this like only human readable PDF on the left and turns it into something that a model could actually understand. So just like plain text with like latex formulas where applicable. It even breaks down like tables into like latex tables.
Talk about this. So Llama 2 only has like 4K context length, and then the average token length of each paper was like 10K. So we had to chunk it somehow. And so, I just loaded in the Llama tokenizer, and then I didn't want it to chunk mid-paragraph. So with the Meta, OCR thing, it does its MMD, the markdown, really interesting, where it breaks it down, where it's like 5 hashtags abstract, 5 hashtags, another section. So I said, prioritize the longer hashtags, chunking at the longer hashtags. So that resulted in some pretty cool chunking. And then we used parameter efficient fine tuning to be able to fine tune this pretty quickly on A100. And then we used code-llama specifically because we also knew that the latex would be some of the output. And it's been known that code allows for these large language models to reason better. So I thought, maybe some of that will transfer over. And then here are some of the outputs. Oh yeah, by the way, before is the non-fine-tuned, after is fine-tuned.
Yeah. So we asked it just a simple question. What is simplex diffusion? This was one of the papers that colleagues shared, that AK shared. The top non-fine-tuned one talks about diffusion in the chemical sense, like liquids diffusing through substances. And then the fine-tuned one gives an actual explanation of simplex diffusion from the paper, which, to be fair, it did see in its training. And it even managed to write some pretty nice latex, which we were able to render. So yeah, pretty cool. The same thing even applies for GPT-4. So in a sense, we've outdone GPT-4, where of course GPT-4 doesn't have any idea of what diffusion or stable diffusion or this random simplex diffusion paper are. So here you can also see that at least GPT-4 did recognize that it's not entirely sure what's being talked about, and then I would same output from last time. Another sample of us asking it to explain the math behind stable diffusion, and again the base model again talks about diffusion in the chemical sense, and then the diffusion from the definition from our fine-tuned model is pretty interesting, where it presents these beautiful equations and actually presents a very nice explanation of stable diffusion, which is honestly pretty impressive in my opinion. Same deal here, don't need to.
So at the bottom you'll see in finance, stable distributions, blah, blah, blah. So the thing about these other models is that they try and be as general as possible, due to RLHF and just due to the very large training data set. So with fine-tuning on this domain-specific data set, you sort of nudge it towards that direction with every single output, which is exactly what we want in this kind of research assistant.
Yeah, and then finally we figured this is an LLM hackathon, so we should also have some questions about transformers. And again, the base one is just making random stuff up, which doesn't make a lot of sense. And then the method within the destination from our model is actually exactly what the meta paper that this refers to talked about. So I guess what we've shown here is that it's definitely possible to teach these models specific concepts. obviously this doesn't necessarily mean that, like having vector embeddings would be nice to always be up to date with all the latest research, but this was sort of our way of catching up all these like models trained on like data from a couple of years ago to like all the latest advancements in AI, thanks to AK.
Yeah, and to expand on that, like this versus something like, or just retrieval, the cool thing about this is that if you have so much like research papers, it can eventually potentially like start trying to blend ideas, see the overlaps. Whereas with something like retrieval, you're always like limiting the actual context that it sees, which was somewhat might actually limit the creativity of the model. And so some things for future ideas is like, I have so many bookmark tweets, it'd be cool if it just like scrapes that. And then domain-specific archive papers would be cool. And then even like selected books. And fine-tune for longer, because we only fine-tuned for like maybe 45 minutes or something. We had to really cut down on the fine-tuning steps due to the time requirements. So I do think the performance would like significantly improve if we just let it fine-tune for longer as well.
Yeah, for sure. Before we ask questions, just we can shout out to Meta for all these incredible models. Truly, truly awesome.
Was there a mix of how much new data, specialized data, you uploaded before it started being smart?
No, we only put like new data in, so we only uploaded, like we only trained it.
And that was the 45 minutes you were talking about?
Yes.
What about training it on Sci-Hub, like what the previous presenter was talking about?
That's a pretty interesting idea, yeah, definitely. I mean, even expanding it to fine-tuning on a lot more papers from Arxiv or Sci-Hub is a very exciting route. I think this model, like, the outputs we had were like pretty like cherry-picked, but I think it sort of is a proof of concept that there is capacity for these models to like learn very specific range concepts.
Also, there's things like less is more for alignment that has shown that it's not necessarily about like just more data. It's about like this like very high quality data that is going to be applicable to what you want. So it's the way I think about it is like don't always think about what you should do, just kind of like what makes sense is kind of what we did. Any more questions?
Questions. First one, how did it behave when you prompted it a concept that was not fine-tuned? And second one is like, how did you fine-tune it? What was your step?
We did a lot of testing. So.
Yeah, I guess the outputs were all pretty like hit or miss. Like I think the ones that I showed that I was pretty impressed by, but a bunch of them were not very impressive. And yeah, I guess I didn't explore enough, but overall I was not impressed with it coming up with totally new concepts. In terms of the fine-tuning, we did just like parameter efficient fine-tuning, used code-llama 13b.
In terms of coming up with new concepts, the idea I had that unfortunately didn't train long enough, but the idea was that like in the prompt you can put in like a title of a made-up research paper and then a made-up abstract and then have it fill in like the introduction, methods and whatnot. Basically create this imaginary research paper based off of this like seed of an idea, but it didn't fine-tune long enough. And in the fine-tuning method, so there was a chunking, but at times I felt like it was losing information, so I made sure to include the title appended to every chunk. That way there was still some link between each chunk. What I should have done, we didn't have time to experiment more, but what I would do differently is I would include the abstract, the title and the abstract, along with everything else. Even if it's like 3 sentences from the abstract, I think it's important to like link chunks somehow, so they're not disconnected. Yeah.
We also have to put the model on Hugging Face. I can share the link in the Slack if you want to clear out. Any other questions?
Any other questions? Oh yeah, there.
I'm curious if you guys have noticed any sort of synthesis behavior whereby like the questions you asked presumably were in the training data, like the exact paper that started it. Curious if you sort of mentioned or searched something that was sort of one paper mentioned offhandedly, another paper mentioned offhandedly, but wasn't the thing they all both mentioned were in the training data, whether or not the model can synthesize still through that.
So we honestly did not like look through like every single paper in the training data, so I can't be 100% sure. But Stable Diffusion was released like well before the cutoff for the data that we included.
Awesome.
And so yeah, I think like it gleaned like info for Stable Diffusion from other papers.
Awesome. That's very cool. Thank you.
That's good. Yeah. Cool.
All right. Thank you.